and mu naught is the vacuum permeability, and its value is equal to 4.2 10 raised to power minus 7. So I can have a number of air gaps in completing the path for the flux, and the air gap length for a single gap can be calculated as dividing the sum divided by the number of paths. For example, in a double E type core, I get two number of air gaps in completing a single path for the flux. There are a number of things that should be discussed with this inductor design, but I think this is enough for the brief overview of this inductor design, and these are enough, and using these calculations you can find the inductor dimensions and the air gap. So let us go through these steps once again. Using this equation you will get the value of AC AW. So for example, if we get some value AC AW is equal to 1000, and you have no means by which you can calculate the AC and AW independently. In that case, to simplify calculations, you can consider both of them equal. AC into AW, they will be same, so I can consider them equal to A square is equal to 1000 and whatever the units. So using this I will calculate the core and omega. But outside an exam, if you are provided with the values you have an access to internet, and if you are provided with a course with a number of cores, so in that case how will you decide which core to select? So in that case you will find this area product ACAW is equal to whatever this value is equal to 1000. So you will go to internet, look up for some standards. For example, you will see EE70, EE80, 90 and up to so on. So using the data sheets of this EE core 70, 80, 90, you will calculate, you will determine independently AC and AW. You will multiply both of these values and you will check if this value is equal to or greater than this product. So less than this, if the product of ACAW that I've determined from this data sheet is less than this area product, then I will obviously move on towards the next one and will check whether it satisfies the minimum requirement of this area product. If it is equal to or greater than the area product that I have calculated over here, I will select that core and I will get an AC and AW independently. Okay, so I have this area product now. On the basis of this area product, I have selected a core that is either EE70, or there can be also some other standards EI. In that EI 70, 80, 90, either one of these standards will be selected, and then the next step is to find this reluctance. It will be used in another equation to find the summation of this L air gap, and then this L air gap will be divided by the number of air gaps, and I will get the air gap that I need to have between these cores in order to avoid saturation. So that's it. Thank you very much.